is unwell, so he'll not be joining us. He won't be joining us today.
That makes two of us. I mean, who are unwell. I'm joining. I'm here, but I'm not very well as well. So.
Oh, sorry, Willa.
Yeah, it's fine.
Okay. Okay. So, so I think we can begin. Ellie is taking notes. So there was nothing that was slotted in for the agenda today. It seems there aren't many issues to discuss. So I think we'll probably just start off with the to-dos. And then move on to the A or Bs if there'll be any. How does that sound?
Regan?
Yeah.
I remember last time we had this call, we suggested that Bark is going to present on EID. That was one of the agendas for this week. Actually, I think it is on to-dos for last week.
Yeah. So actually it's the second to do. So I'm hoping we can get to it after we finalize the first one.
Yeah, you know, what I'm trying to say it was supposed to be the agenda for today. Because, you know, the to-dos, I think they are the things that we are supposed to do, not on the call, outside the call. So it was, anyway, I think either it's fine. So just let's proceed. Yeah.
Okay, understood. So I get it, Willa, but if you don't mind, I'll just go through the first one, the first to do, which was the creation of an awaiting approval status, ticket status. So I don't know if you all had a chance to review the current tickets and to add it. If not, that's fine. I guess we can probably schedule it for next week's review, you know, as a to-do item.
Yeah, so Bark, I didn't do anything on that, and I'm not sure if Bark did it, but we can check. He's here, so he can respond, I guess. But
hello, can you hear me? Hello.
Yes, Bark.
Hey, Bark, we can hear you.
Oh, you can hear me now.
Yes, we can.
I was talking and.
Okay. On mute. To yourself.
Apparently. No, I added the waiting on information, or not waiting on information, the waiting on approval. I added that last week, and I put a comment on the developer actions or whatever the page was, activity, developer activity. You know, that noted that, and also asked some questions about about that page.
Okay, thanks, Bark. I guess we'll probably wait until that process, the approval process, is done. But you know, as you mentioned last time, we'll probably keep using the existing ticket statuses, and you know, just adding in comments as necessary until that particular status is there for us to use.
I'm sorry.
I think everybody.
I'm sorry. Maybe you misunderstood. I did that last week. It's done.
Oh, sorry, Buck. Awesome, that's awesome. I don't think any of us has had a chance to try it out, so I think we'll give it a try. Thanks a lot.
Yeah, what I said, I don't know if maybe I didn't come through. I did that last week, and I put a comment on the developer activity page, some comments. You know, I mentioned that I had done the waiting for approval, and so you could start using it. But I also asked some questions about that page.
Okay. Okay, thanks, Buck. I mean, we haven't. I never looked at the developers priorities page, and I certainly didn't respond to the question that you raised. I think we'll have a go at it with the rest of the guys. We'll give it a try and bring it up as as an issue next time if there's anything that if there's anything that needs to be discussed about it. But thanks a lot.
Oh, it's called tickets activity.
Yeah. Ah, okay. That's the list that we created.
Yeah.
Ah, okay. Just okay. Thanks, Buck. We'll definitely respond. What was the ticket which was the presentation to AMRS interface? What do you think you got?
Yeah, I can try.
All yours.
It does depend on some internet connectivity, so hopefully you'll be able to see. Are you able to see my screen?
Well, yeah, but right now we're looking at your. Yeah, we're looking at your face. Oh no, the screen just came up. Myth appliance.
Yeah, Mirth. It's the same. It's just like Burke. If you can say Mirth, you can say Burke. But mostly when I'm in Kenya, I get called Bach. So it will make me sad if everyone can say Mirth, but they can't say Burke. So Mirth is a tool. It's an open source interface engine. An interface engine is a tool used by many hospitals and healthcare systems once they get large enough to have multiple systems. The notion of an interface engine is that it helps communicate between different systems like radiology, laboratory, the EMR, maybe registration and other systems that might be running at the same time. And that's what HL7, which I think you guys have seen here and there, was a standard way of communicating events in a healthcare system. A message, a protocol for how messages could be sent about events that occur in a healthcare system. And Mirth focuses primarily. It can work with other formats, but its primary purpose is to help shuttle those HL7 messages around. And in fact, it's designed to kind of take a lot of the work out of that in terms of presenting queues of messages, because one of the things, as soon as you get into trying to take system A and system B and have them speak together with HL7, you quickly learn, as everyone else before you has, that it's not so simple, because sometimes system A is down, sometimes system B is down, sometimes just the connection itself may break, and so it takes some time and effort to sustain that and kind of keep it running. And Mirth tries to help with that by providing a application where it has a receiving and sending queues. It will, if you send it messages and it can't yet send them to the other application, then it will queue them up until it can get them communicated. So there's also the primary, one of the primary roles of Mirth is to do simple translations of the messages. So it lets you take an HL7 message that's coming from one system and kind of mutate it or change it a little bit into the format needed by another system. And HL7, again, when people work with it enough, they realize that while there's a specification, a protocol for communicating, a lot of systems don't follow the protocol exactly, or they might interpret it a little differently. And so that ability to manipulate the messages as they go by is a very powerful and important aspect. So that's what Mirth Appliance is, basically that open source application, and then Mirth, the company behind that open source project, makes some of their money by they make most of their money by providing support. But one of the ways they also make money is by selling these server boxes that are pre-installed with Mirth and some additional software to make it very easy to manage. And they were kind enough to donate two of these appliances to Ampath. So that's what Mirth is. Is there any questions about that?
Yeah, Mark.
Yes.
I was just thinking, can I think of Mirth as some sort of crowbar?
Did you say Clover?
No, crowbar, CORBA.
Crowbar.
Crowbar, common object request broker, like a.
Oh.
Yeah.
Oh, Corba. Okay. Um, kind of. It's a little less specific. I guess I'm not as familiar with Corba. I know I've seen it before. I'm not, it's been a while since I've looked at Corba, so I'm not as familiar with what it's trying to accomplish. It's basically sharing objects through an enterprise. Is that what the Corba is?
Yeah, through a common interface. It's like I think it's more like it's sharing objects between different applications actually.
Yeah,
Yeah.
I think of Corba more as something that is doing that, sharing resources, and I think of Mirth because HL7 isn't about objects so much; it's about events that are occurring.
Yes.
So I think of Mirth as more of the messaging. It's more like the switchboard for a phone system, where it knows there's callers 1 through 100, and any message from caller 2 needs to go to these 50 callers, and any message from these 10 callers need to be copied to this other place, and so I think of it more as a switchboard funneling these messages, and like the National Security Administration in the U.S., it not only will move those messages around, but it might change them along the way. So it's yeah. So it kind of. I mean, it's a centralized. The idea of it is that it allows when you want to communicate from system A to system B, you can solve that problem. You don't really need Mirth. But when you want to communicate from system A through Z to systems 1 through 100, Mirth allows that process to be kind of a linear process instead of an exponential one in terms of the amount of work involved.
Okay.
So, any other questions?
Maybe just one, Buck.
Yeah.
So you said that Mirth's primary role is to shuttle around HL7 messages, right?
Yes.
So assuming I'm creating a healthcare-based application that needs to interface with another, then I probably need to convert all my messages to HL7 for Mirth to recognize them, right?
That's not totally true. Mirth can do other types of messages. It doesn't really care. It provides, and we'll step into it and I'll show you. It works with channels, and it has a bunch of different types of channel receivers and channel senders, and those are the kind of, does it look in a file, in a file system? Does it look in does it listen on a TCP port, that kind of thing? And then when it receives a message, it really can be almost any format of a file, but its specific strength is around HL7. So since a majority of healthcare messaging is done in HL7, that's where Mirth really sings. That's what it's designed to do. But at the end of the day, it's basically it has queues, and connectors where you can send a message in, could be any format. It could be any kind of XML, JSON, probably even a binary file. But then it has Rhino, JavaScript libraries that will let you manipulate the message if necessary, and then it will send them out. So they've designed the JavaScript and the kind of tooling for that. A lot of it will work really well with HL7. You can make it work for other things.
Okay, cool. So if I got that last part of the statement, what you're saying is for any apps that are developed to submit data to math in HL7, then there are tools that allow you to convert whatever you're sending to a format that's compliant with math. I hope that made sense.
Yeah, it actually can work either way. You could send JSON or XML to Mirth and have it spit out HL7. So
okay.
it receives data and it sends data, and HL7 is a strong point for it. It's designed because most of communication is HL7 in healthcare systems. That's where a lot of its strength is. But there's nothing prevents you from sending JSON or XML and sending out JSON or XML. It's really about getting messages from one system to another.
Okay, thanks, Buck.
Now, is this screen share being recorded?
Yes, this is being recorded in YouTube.
So I'm going to try to be careful not to show any patient information. So I don't want to show an HL7 message itself. Hopefully, folks have seen that before, but I'll try to stay just at the system level. So
yeah.
So you'll notice if you can, it may be too tiny to see on the screen share, but there's two Mirth boxes, Mirth 1 and Mirth 2. Mirth 1 is what we're using in production, and Mirth 2 is just a second server, and we've managed recently to get it upgraded to where it has the latest software, and and it is the purpose of it is really to be a backup for Mirth 1. It's possible to set these up as clustering, and I'm still trying to learn about that to be able to do that for these machines. So that really the notion is that we want to have a Mirth running, and then we want to have a failover system in case that server should fail, that we can turn to the other one. Where right now we have the hardware and we have the software updated for it, but it would not be a happy day if Mirth 1 went down. The primary function for Mirth right now is taking messages from EID, which is the early infant diagnosis, I believe is what EID stands for. And that's the system that is being used to collect HIV results and other important information for diagnosis of HIV in children. And that's donated, I think it was through the Clinton Foundation, and then they also get a number of lab reagents and other things through that. So they need to report those through EID to meet the requirements for that funding source. And so what we managed to do was to get EID to create those copies, essentially CSVs of, and here's an example where Mirth is working with things that are not HL7. And so EID, we worked with them and got them to basically save their data as CSV files into a folder on the EID machine, and then we have I believe it's probably a Windows task running on that machine to send those CSV files to the Mirth box. So essentially, EID machine is delivering CSV files, and those CSV files may contain one patient, but most of them contain one row for a result of a patient, and one CSV may have a dozen or a couple dozen results, meaning that it's results for a dozen patients in one CSV. And so that's what we're getting from EID into the Mirth box. Does that make sense?
Yeah, that makes sense. I'm still, I guess maybe this is just me. I'm still struggling to understand how flexible math is.
Yeah.
You know,
So
I
we'll get
mean,
to that. I'll show you some of that. So in Mirth, we have there's several ways you can receive files, but one of them is through folders. So so there is a kind of a file system, and I think it's the inbox that contains these. No, I don't see it on here. Oh, it's secure FTP users. This was probably created by Jeremy or something. So there's EID, and then PCS is the lab system. So essentially, there's a folder. There's a folder for secure FTP, and then he's created user accounts for EID and PCS. This may be this is basically he's set up accounts where those two systems can log on securely and and then deliver their data as files. I think we can look at EID. I don't think there's any patient, and so it's under I think files and then inbox. I think. Yeah, and so here's there's two different results that we're getting from them right now. Viral load and HIV, and these are separate. We keep these separate because they get processed a little differently. So so if we if we go to the HIV results, there's nothing there because they've been processed, and nothing there. So there's, I think the reason those are empty is that they've been processed. So if we go, yeah. So here, these we're not going to open any of these because they have data in them about patients, but basically these are CSV files that have been moved from the inbox to a processed folder after they've been handled. So essentially, what you're seeing here is just there is a kind of a little kind of file system, and it's possible through the administration screen to manipulate and kind of create new folders if you're going to set up a new system to send information. One of the things we'll want to do is to get folks accounts on here. Anyone who's going to be supporting the HL7 system, we should probably make sure they have an account on here because they're kind of managed individually. So Jeremy set this up. I got an account so that I could help out, and Chege has an account, and I'm not sure who else has an account on here. So let's see. So Miencha, myself, Chege, Jeremy probably should get removed now. Willa, we've gotten Willa an account, and Thomas has an account, and Victor. So, largely it's lab and IT managing this, and that's what we want. We don't want it to be developers having to spend a lot of time managing the flow of these. We want you to be aware of it, but we probably would do well to have if we have at least a couple folks that have an account on here. There isn't a rich roles system. Basically, I think if you get an account on here, you can do anything. So let me show you. So there's a little bit in terms of just basic functionality and management administration through this web portal, but a lot of the actual communication and managing of messages happens through a web. There's a Web Connect or Java, a Java Swing application that does most of the work. So it's called Mirth Connect, and if you were there locally, you could just launch the application directly from this website. But because I'm remote, I have to do a little trickery. So basically, I'm in Firefox running a plugin off in the side that that does a proxy switching, and I have an application called SSH Tunnel that is basically redirecting ports. So to be getting to this from an external site, basically I'm connecting through our SSH Ampath ORKE, and then making a connection through the SSH server and then redirecting ports. Most of the guys in Eldoret don't need to worry about this. You would be local. But as a side effect of using that, I have to edit these JNLP. So these are the web start. This is what a file, a Java web start application. And if you look at it, it's just an XML file, and it's running Mirth Connect. But I've had to change the ports that normally would point to the Mirth box to point to my local host. There's a couple places where they make reference to the IP address of the server itself, and I've had to save that file and then edit it to point it to localhost with my proxy switching to get it to work. So really, that only is significant for Willa or Win or myself, who might have to get to these remotely. And I think Willa, we've already kind of walked through this. I don't think Win has. So I'm going to go ahead and activate Mirth1. And this is basically just a Java application, a Java, Swing application that that connects to the Mirth server. And if it is truly mirthful, if it's happy, it will connect. The connection isn't particularly fast right now.
Bert, I wrote a question in the chat. I don't want to talk because it seems that if I talk, the screen sharing is switching to my screen.
Oh, that you can stop that by that just happens if you haven't selected my screen.
Oh.
If anybody wants to watch my screen in Google Hangout and they don't want it switching to whoever's talking, they can just click on my screen and it'll stay there. And then if they are tired of looking at my screen, they can click it again and it'll go back to switching to whoever's talking.
Oh.
So feel free to talk.
Okay.
What was your question in chat?
So do the apps basically just drop a file in the folders of the Mirth?
Yeah, so I'll show you the connections, but right now that's the primary way we're delivering. It's only one of many ways you can deliver data to Mirth, but right now that's the way we're using, is for both the lab system, which the lab system is delivering data directly to AMRS, but we're also sending it to the Mirth box. The idea was that we would start using Mirth as the delivery vehicle for the lab system as well. But Jeremy had that working in parallel and was testing it out, and but didn't get it fully turned on. So now that we have EID going through, I think it's the PCS the PCS messages are pretty much are going unchanged through Mirth. So it should be fairly easy to get that to where Mirth delivered all the labs data as well. As it stands, it's essentially serving as a backup because it's just loading stuff into Mirth and
right.
and it's not. So yeah, this is depending on the connection to Kenya. This will run a lot faster in Eldoret when you're connected directly to the server. It's almost instantaneous. Hopefully it'll start up. But I'll show you if we get Mirth Connect to actually load. I'll show you the kind of options for types of connections you can make, and you'll see, it's not magical. It's things you would expect in terms of how would you want to be able to deliver data to a server. So you can do it by files. You can do it by TCP connections. You can do it by direct port communication. You can do it by, I think there's probably, I don't know, email, other. All right, I'm getting logged in here. I'm making progress, and then I'm not making progress. Is this? Progress being taken away. Now I'm making progress, so now it's taken away. Once this finally shows up, it shouldn't be slow. It should once it's set up. It's I guess loading channels and things can.
Yeah.
Sluggish.
I think it's about time you download video from Dailymotion or.
Mirth Connect. Oh no, we just upgraded the. That's what's happening. So we upgraded the server. Man, let me see if I can get connected. Where did that go? So it's in downloads, WebStart 1. Okay, so now you have to see me do the dirty work. I think those are the only two places where the IP address is. So now
Pretty slow.
Yeah.
Regan and team, do you guys have any question?
Uh-oh.
Actually, we're watching a really cool video. The title of the video is "How Does HL7 Work?" So, we're hoping to be up to speed to Buck's level by the time the download is done. Anyway, so we're following. I guess one of the things we're really looking forward to is to see exactly how that magic happens. And I know you probably can't show us the CSV files, but I guess I'll spend some time to look at them because I'd really love to see how the CSV files look like, what their schema is, and how the HL7 output looks like. I think that would be interesting.
Yeah, so we got the HL7 pretty much whatever we could get from EID we had to take, and so it's basically the information they have is, fortunately they do have the medical record number, and then they have name, and then there's there's a few dates of like when the test was drawn versus run, and there's probably maybe 10 different columns of data in what they give us, and the I think you can see that in I think there's an EID. I ran 2 instances of that, so hopefully one's still. The connection to my connection was lost. Can you guys still hear me?
Yeah, we can hear you.
Okay. All right. There is on the wiki, here it is. And EID, EID to AMRS. That describes the process of getting the data. And so these are the we analyze the CSV files that we got from them, and as you know, if you've worked with worked with other vendors, what they say they will give you and what you actually get can always vary. So we negotiated in terms of getting these columns from them. So lab ID is basically an incrementing number. Sample ID is actually the patient identifier. They give names, but it kind of varies what we get there. The facility, which is a facility name, which is listed below, and then there's several dates, and then there's a interpretation and a test result. And I think the test result is what the machine gives, and the interpretation is what. Well, no, maybe it's the opposite. Maybe interpretation is what the machine gives, and test result is what the lab person, how they interpret it. Okay, now Mirth is starting to get there. So, but this you can see there's the various. I don't know how well you can see on my screen, but the various columns that we're getting from them, and it's a straightforward CSV. I don't think it even has quotes and things. There's a number of facilities that they may list, and so we have those listed. And then we went through basically a value by value in terms of how we would interpret the different values within that CSV file and convert them in the HL7. And then we have some documentation on how errors are handled. So, and then these were the steps we created to try to work through this. And we are working through AMRS 200. So, let's see if Mirth is getting any closer. Oh, I'm back to the cyborg window.
Can I ask something, Buck?
Yeah.
So you mentioned that Jeremy had 2 kinds of connections going, 2 kinds of interfaces. Okay, should I ask, or do you want to go on?
Well, he had basically there were 2 there are 2 things we're getting. We're getting HIV DNA PCR, which is PCR is a way of detecting whether the patient has HIV. And you'll see that result as either positive or negative most of the time. And then the viral load is actual measure of the virus in the body. That's like a number of how much was seen in the body. And so the result is often a number. So those 2 different results need to get treated a little differently. That's why there's basically 2 different channels. But then what they do is we have a HL7 to AMRS channel, and I don't know how I can zoom in a little bit this way. There's EID to HIV DNR and a viral load, EID viral load channel in which those results come in, and then they both send to the HL7 to AMRS channel. So they basically receive the CSV, make an HL7 message, and then send that to the HL7 to the same HL7 to AMRS channel, and that HL7 to AMRS channel is basically responsible for taking a message and sending it to AMRS, which basically is putting it into using SFTP to put it into a folder on AMRS. So.
Okay. And what happens using the second? I mean, like, if EID can submit directly to AMRS, isn't there a fear of duplication? Because like having the same record go through math and the same record go directly to AMRS,
Yeah.
and how does that even work? Like,
so that's
like
that's true with the PCS, the lab system. That is not the case with EID. EID doesn't send anything directly to AMRS. So
okay.
EID is only sending through Mirth because we had Mirth set up in time to receive these EID. The lab system was connected to AMRS long before we got the Mirth boxes. So it has always been sending directly to AMRS. We created a pathway for it to send through Mirth so that we could have a single interface, for external systems to send to AMRS. And that has been kind of worked out. It's pretty much close to working, but it hasn't been turned on. So at the point that we were going to turn on messages going through Mirth from the lab, from PCS, we would want to turn off the direct delivery and then turn on the sending it to Mirth. So yeah, we wouldn't want to send both directions and hope for the best.
Okay.
So hopefully there they come. So here you see the individual channels. So the way that it may be hard to see. Let me zoom in. The way Mirth works is the notion there are these channels. Those are kind of the lanes through which messages are delivered. And channels, basically, they have an input and an output, and then you can they have tools to filter messages going through them, and then to manipulate or transform those messages. So you'll see the data type column. I can't really point to it because my screen moves around, but you'll see there's delimited text, and there's HL7. There's another one we're testing some samples, and that was XML. But you can see the data type varies in terms of, and that can be the data type. It's basically the data type handled by that particular channel, and so that can vary. You can have channels that handle different types of data. So let's look at the EID PCR channel. So this is the actual definition of the channel for the HIV DNA. You can set the data types, and those are going to control both coming in and going out. So it has inbound and outbound, and for the particular type, you can actually set these additional properties like are things quoted, what delimiters to use. So you can get very specific in terms of details about not just, oh, this is going to be HL7, but this is HL7 with these characteristics. Same way with delimited text. So you can see on the inbound, this is saying I'm getting delimited text, which is a CSV. It's delimited by a comma. Oops. It's delimited by a comma, which makes it a CSV. There's a new line between each row, and if anything is quoted, which I'm not sure they are in this particular, but if anything's quoted, it's with the quote character. How to handle double, escaping of quotes. So that's the level of detail you can get into. Does that make sense? So basically, you're saying here's what's coming in and here's what should go out, the format, and basically each one has maybe some details about that. Does that make sense?
Yep.
So in the HL7, you can see the outbound going for HL7. There's different characteristics you can say, whether to strip namespaces, to how strict to be, and et cetera, et cetera. So they have some different properties you can reference in terms of even with the HL7. That's that defines kind of the data types, what type of data is coming in, what's going out, and then you can set the level of what gets stored in terms of logging. You can have it prune or eliminate messages over time, and basically this is saying, then you can create some custom metadata. So those are all different kind of just details. This is a summary of it. If you look at the actual definition of the source, so this source for the channel is what's coming in, destination is what's going out. So the source, it's saying I've got this directory where HIV files will be dropped. That's what it's gonna look, and the method is file. So if I open up method, you'll see, this is, so that, I guess its method is because those are all different kind of deliveries of files. Oh, that's because this is a file reader. That's where it is. So here you can see some different types of readers. So a channel reader means it takes data from a different channel. DICOM is a standard for kind of radiology systems. Database is reading directly from a database, so it could make a connection to some external database. So for example, if EID had their data stored in Postgres or MySQL, you could define the connection, for the Mirth box could actually make a connection to that database and pull from a table. File reader, it can listen via HTTP, it can do JMS, it can do JavaScript, and then TCP, and then it has a web service. So those are the different ways you can get data into a channel. So the rest of this is just details about how to handle the data coming in, where to put errors, etc. And if we look at the destination, it's this basically defines where do the messages go once they're done, been processed, and you can see it says send to AMRS, which is basically another channel. So, and then it's saving a raw archive of everything it processes. So if you look at where is it? I have to be on the source. Okay, so if we look at the source, there's filters. So here, this is using Rhino, and it gives you the ability to specify in JavaScript what to do with the message. So these are basically filters of what will get refused, or essentially won't go through this channel. So basically what we're saying is up front, the way Mirth works with its channels is you basically first use filters to ensure that you have a valid message, and then there's another step which is well, I have to go back to the channel. There's another step called transform that does the actual transformation, and the assumption there is that you've already filtered out invalid messages. So we'll go back to the filters. So essentially what this is saying is that we're looking at specific columns in the CSV, and we're validating and making sure that the things that we need to be there are there. So for example, you can see the reject message if the test result is not one of these known, like if it's anything but one of the acceptable values, then we reject the message. So that that allows, and then this is JavaScript down here. This is actually, so I'm on reject if the lab ID doesn't contain a positive integer. So this is basically looking at the first column. So you see the message. I can't really select because my screen moves with my mouse, but we're looking at the message, the current row and column 1, turning it into a string in JavaScript, and then doing a regex to see that it's just digits in there. And if that fails, then we set a message to say this is invalid. So this is the kind of stuff that if we run into, if we need to make new channels, that Chege or Miencha aren't going to be able to do this stuff. Myself and Jeremy setting this up, we're not exactly like the super mirth experts. We did a lot of Googling to kind of put this together, so it's not expected that we'll set up a channel next week and that developers will have to be able to do all this. But it is very possible that if we have to set up channels, we want to, like on the next channels we set up, we want you guys to be doing that, and then myself can be as kind of a consultant. But we want to get to where the folks in Eldoret are touching this and kind of helping create the next things, and as issues come up, you're part of fixing them. So where a programmer gets involved in is in this filtering. There's JavaScript involved, and then if we look at the transform, we don't do transforms on the source, we do transforms on the destination. So you can see I have 6 transforms in here. So what you do in these transforms, you'll see down in the bottom right here, this is what an HL7 message looks like. So it may hopefully look something similar to what you may have seen in the video, but it's basically vertical bars. Each, I can't really point to them with my mouse because my screen's moving, but you'll see the first line is MSH, the second line is PID, and then OBR, OBX, NTE. MSH is called as a message header. Each line in this message is called a segment in HL7. And PID is a patient identifier. OBR is basically a order or observation result. And then OBX is the actual observation. NTE allows for, I forget what NTE is, something text exception. It's basically a way to include a comment if you have an additional comment about the result. And what is not typical HL7 in this message is the things you're seeing in curly braces. The curly braces are little markers we're using to we're using those as placeholders for the different components that we're going to fill in as we transform the CSV. So essentially the things you see in braces like identifier, patient name, comment, the answer concept, so these things are getting filled in based on the JavaScript we're going to run. And then the rest of the message, though, the rest of the structure, like this 99 DCT and all these vertical bars, etc., those all the segment names here, those are all templated in. They're just there, and that's what the message will look like. It's basically going to look exactly like this template, but with the curly braces replaced with actual data. So essentially that's what Mirth allows us to do, is to define a template and then fill it in, basically fill it in the places we want as we process the message. So we'll take, for example, the patient ID. That one is a direct transform. So we take this is the third. This is basically the PID as a patient identifier segment, the third element, and the first component of the third element. So we're saying where to put it in the HL7, and this is saying out of the current row, taking column 2, make it a string, and take any white space out of it. So this particular transform is just using some built-in functionality of Mirth, where you can literally say the mapping is where in the CSV, the incoming data, where to get the value, and then the message segment is saying where in the outgoing message to put it. So this is really saying take column 2 and put it into the patient identifier segment, in the third field. So if we go back and look at the template, it's basically PID is the patient identifier, is the segment we're interested in, and the third field is where the identifier goes. And so the vertical bars separate fields, and the circumflex is what separates components within that field. So, so that's cool. Third field, first component is what the 3 and the 3.1. So that you get these nifty little JavaScript-based, it's just going into hashes, but it gives you a notation that's fairly easy. Once you're forced to do it and kind of learn what these things are, they're fairly easy to refer to. So a lot of these are just straight. The answer needs a little more attention. So just so you can see what it's doing, it gets column 11 out of the result. So that column 11 is the test result, and we're actually mapping it to specific concepts. So you can see we pull out the result, and then we see if it's the word negative, we map it to concept ID negative, to the concept negative. If it's positive, we map to the concept positive. If it's failed, we map to failed. And the reason we know it's one of those 3 values and nothing else is on our filters, we made sure that those are the only possible things that can come through. And the decision of exactly which concepts to use was made on the wiki page, where we kind of worked through how we were going to transform everything, and this is actually just doing that work. So it creates a concept and gets an ID, the name of the concept and an ID, and then it sets those values down below. And we have a place that if we have a comment, we'll put it in. Otherwise, we get rid of the NTE segment. So the point is not to learn all this right now, but just to see kind of it's in there, be aware of it at this stage. So effectively, we have a channel that is taking the source, which is CSV files delivered, and filtering out those that are invalid, and then taking all those that are valid, which hopefully would be all of them, and running through these little JavaScript rules to fill in a template that is in the format for HL7. And then the destination is to send to AMRS, which is a channel writer. That's a channel writer, which basically sends to here, HL7 to AMRS. This is where we specify the channel we're going to use. So if we go back to our channels and look at HL7 to AMRS, this is a very simple channel, which basically is source is a channel reader. So basically this just says other channels are going to send me things, and then the destination is going to be a file writer, and it actually does SFTP to AMRS, to this folder within AMRS, and it uses whatever the file name is, and it has a login, and you'll see it's using a PCS login because that was created in AMRS to allow for the lab to log in. But the truth is that it can work as well for Mirth to connect. So it's basically, you can see here, it's literally making an SSH, a FTP connection, a secure FTP connection, logging into AMRS and writing the files to a specific directory. And that's all the job of this channel is to do. So a lot of this kind of configuring it is hopefully over time is something that between Chege and the IT team, they can understand or learn. But when it comes to the specific JavaScript things, there's going to need to be some developer engagement. So I know we've gone over. I wanted you guys to be aware this is out there, and then we can work on trying to get you guys involved as opportunities arise and we see fit. Sorry for going over. Are there any last-minute questions?
Yeah, so maybe I could ask two. The
Uh-huh.
first is so there was a web interface, right? The first thing that you showed us before you launched the JNLP, the
Yep.
web start. So what are the differences? Like what can you do here on the web interface that you can't do on the other one? That's the first. And then the second question is, I bet Math, like any other application, has its own error logs. Where could you view those error logs? Like for instance, if something was on a channel and that never got passed off, maybe to
Yeah.
AMRS for one reason or another, maybe the CSV wasn't well formatted. Like where would you view that? What would be the log for that?
Okay. So the first question, the what you see here, the Java, the Swing application, is is basically a is basically what you get from the open source project, Mirth Connect, and that you get that with a a little bit of additional code from the open source project to basically that's the key engine that is moving the messages around. The web interface is largely what you get from getting a Mirth appliance. This is what the company behind that open source project, where they're making their revenue, is by making it easier to work with Mirth, by making all this manageable out of the box. So all of this web application is this is kind of the commercial side of what the Mirth company provides, and and um, so this thing, the Swing application called Mirth Connect, is really the engine that does all the transforms and manages all the transforms. The website is what what you may first open up when you first work with the Mirth appliance. That is basically the giving you all these kind of conveniences in terms of managing. So if we were just using the open source project, we would be on our own to set up like the folders and get all the the folders where things should go, setting up the server on our own. There are other things that this does, like it will make it easy to get updates. You can set up automatic backups, restore from a backup. You can define different users, create your own folders. They've set up things like clustering, and that's what I'm going to look into. Even managing load balancing and additional things that allow you to scale. All of that stuff they've done as a service, as an add-on, and that's really what the web application does. Is it gives you access to all that functionality. So that's really the stuff that is kind of convenient management above the actual moving of messages around and transforms. And you can see there's Mirth Connect from here. It looks like there's a Mirth Connect web dashboard. I haven't tried that one. I'm afraid to launch anything new when I'm being recorded in a public venue because I don't want patient information to come up. But basically, this is the web application is just basically a convenience to manage all the stuff you would otherwise have to do manually if you just were using the open source project. It's backups, restores, etc. So it's the administrative side of running Mirth.
Sorry,
Go ahead.
Sorry, could I just ask something before you move to the Swing app? So
Yeah.
back on the web app, there's a graph on the right that shows the number of received messages, I guess, and the ones that have been sent. But it looks as though, so the sent and the error should add up. Wait, so so the received and the error should add up to the sent, right?
No, because the received, remember, the CSV files have multiple records per entry. So the CSV file, you might get one CSV file, but it generates 10 sent messages because those are split apart.
Okay.
So those won't add up because of that reason. So
Okay.
in fact, if you look at the channel, I don't want to. Let's go to channels. If you look at the channel in terms of think it's in. There's a header. Here it is. So here's the little trick right here. In this saying I'm getting a delimited data, there's this property split batch by record. So it's basically saying each record means each row in this file is a separate message. And so this checkbox here to say split it tells Mirth to take that CSV and treat each row in the CSV as a separate kind of message coming through the system. And that's where you get many to one. So there are, to your other question, there is a queue for error messages. I'm a little leery to go into that too deeply because of fear of I'm going to show patient information. But it does track error messages, and there is on the wiki page there is some documentation of looking, that's been scrubbed out, that because we never ever put patient information in the wiki, but that shows you kind of what looking at error messages look like, and you can go through them and actually see the messages, what happened. And so that's, I think Chege and Miencha got some training on from Jeremy in terms of looking into that and how to reprocess those. But the notion is that if you get errors, you can then find out what caused the errors, and either if it's something on, say, EID or the lab side, you would regenerate those, fix the problem and resend those messages, in which case the errors don't need to get processed again. If it was something where, oh, it was something wrong in our code in Mirth, then you might say, I want to reprocess these, I want to take these messages and pre-process them through Mirth. Now that I fixed the bug in our channel. It suddenly got quiet.
Thanks.
So, okay. Sorry that I know it's kind of the 10,000-foot view. It's a fairly quick run through, but at least you know what Mirth is now. You know there's this Java web application out there. The tool itself, if you just Google Mirth, you go to Mirth Corporation, and actually let me go down to directly. Oh, that's Mirth Connect. That's what I want to get to, but that's on Wikipedia. So if Mirth Connect is that swing application, and you can actually get to this. If you kind of work your way through, there is actually, here's the download now. So through here you could get to the actual Mirth Connect and download it, and because it's open source, you can download and get it up and running pretty quickly, and just if you wanted to play around with what is this thing. So we're using now Mirth Connect 3. So that's just something that you could download, and you wouldn't have the data obviously, but you could see kind of if you wanted to play with the application and see what things are in it. So.
Okay. Sorry, I know we're way over time, but just one last question.
Sure.
From the website you just showed us, the MathCorp site, it seems as though the messages that Math can transmit include multimedia stuff as well, like images and stuff. So
this is showing the DICOM. DICOM is the radiology stuff.
Oh, okay. So it's like a data format, right?
Yeah. So my guess is, I don't know if it'll say DICOM. Oh, there it is, DICOM sender. So yeah, DICOM is a like HL7. It's a specification for how to transmit radiology images. So
okay.
That's what these messages show are the actual images that get sent around, and they're just, it's always cool in a demo to show an image, gets people excited. So they wanted to show an image. Did you have a specific question about that, or? Hello?
Regan?
I think we're running way.
Yeah, yeah.
No. Actually, I was just curious because it looked as though Math can only transmit text messages. So I was kind of wondering how it is that images were being shown.
Yeah, yeah.
Sorry, Buck. I think I'll probably have to call this to an end. Way
Yeah.
over time.
Yeah. Sorry for going
on. So the and this is not because the last to do was mine. Not a. Yeah. So but I did have a to. I'll just push that to next week.
Okay. All right.
So I guess unless anybody has something that's really burning, then they can bring it up. Otherwise, I'll probably bring this to an end. Does anybody have anything that's really amazingly urgent?
Nothing from me. Willa left because I think he's attending another call.
Okay. Win, by the way, we managed to run the build and everything looks fine. Thanks a lot.
Okay.
Okay.
Cool.
So thanks everyone. Thank you.
All right,
Thank you,
guys.
Buck.
All right.
Thank you, Bert.
Yep. I'll talk to you guys later.
See you in cyberspace.
See you in cyberspace.